Welcome to VW 4.3. Today we're going to continue our study of functions. So quickly, let's write down the definition of a function, and we'll do the shorthand version. So the basic idea here is every x value is going to correspond to one y value. So graphically, if we're looking at these, the question would be which of these are considered functions? Now what we're going to do is going to be called the vertical line test. What this does is it'll test if a graph is a function. So that's why you see these dotted lines here. So if I draw a line like this, the vertical line test is simply if you can move this vertical line anywhere and it hits 2 points, then it is not a function. So I can see no matter where I put this line, I'll only hit 1 point. So this is a function. So I'll put a happy face. This is a function. Let's go to part B. I can see the same thing. You can put it anywhere. You only hit one place on the graph. Definitely a function. Now here we have a sideways parabola, and I can see right here, notice how I'm hitting 2 points, right here and here. This is not a function. Because you can see that for this x value, let's say this is x equals 1, you can see that 1's going to 1 and 1's going to -1, and that is not a function. And by the same reasoning, you can see right here, we can see that this particular x value is hitting 2 y values, so this circle is also not a function. Now we have a graph. We're going to analyze it here. So it says let this graph, or let f be the function whose graph is given in the figure. It represents a pendulum. And it says the bob of a pendulum is from its at rest position at time x. The negative y values mean the pendulum is to the left, and the positive would mean the pendulum is to the right. So essentially it's saying you have some pendulum like this, and it's moving back and forth. That's the context of the question. Not super important for what we're doing. Let's do A. It says, what's f of 0? So f of 0 is simply saying, if x is 0, remember that's your x value. What is y? So I look right here. I can see if x is 0, my y value is 4. Now we keep going. F of 3 pi over 2. So we go to 3 pi over 2. Right here, I can see the y value is 0. Next one is f of 3 pi. And I can see 3 pi right here. The y value is -4. For a domain, I can see that it starts at 0 and ends at 4 pi. So I'll write bracket 0 to 4 pi. For the range, I can see it's at -4 at the bottom, 4 at the top. So bracket -4 to 4. And I prefer interval. You could use set notation, but interval notation I think is easier here. List the intercepts. So there's kind of a lot here. So we'll do the y-intercept first. That's only 1. That's 4. And the x-intercept, there's quite a few. There's 1, 2, 3, and 4. So pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. How many times does the line y equals 2 intersect the graph? So let's draw in y equals 2 right here. Y equals 2. I can see it intersects it 4 times. 1, 2, 3, 4. So we'll write 4 times. For what values of x is f of x equal -4? So this is saying if y is -4, what is x? So look for -4 right here. I can see x would be pi and 3 pi. Since those are the x values here and here, that produce -4 right here. And this is the last one, inequality. For what values is the graph greater than 0? So if you see greater than 0, think of that as above the x-axis. So I'll just highlight here. I can see we're above the x-axis in a number of places. Here, here, and there. So again, we'll use interval notation. That'll probably be easier. That's going to be inclusive 0 to pi over 2, non-inclusive, union, non-inclusive, 3 pi over 2 to 5 pi over 2, union, 7 pi over 2 to 4 pi inclusive. Now, if you're wondering why only the ends are inclusive, that's because it's ending in these dots right there. And those dots are definitely above 0, whereas these are on 0, and we can't be equal to, since it says strictly greater than 0. Now, the final part says, consider the function. We're going to find all this information. So the first one says find the domain of f. So recall from the domain unit, or the domain lesson, the bottom can't be 0, so I can see x can't be -2. So you could write as an interval or as a set. I prefer a set for this kind of question. So I'll write x such that x cannot be -2. There's our domain. This is a point 1, half on the graph. Well, if I plug in 1, let's see what happens. I get 2 over 3. So no, that point is definitely on the graph because the point would be 1, 2 over 3. If x is 2, what is f of x? So let's plug in 2. F of 2 would equal 3 over 4. So the point should be 2, 3 over 4. If y equals 2, so be careful on this. I'll do it down here. If f of x equals 2, again, that would mean y should equal 2. So you got to plug in 2 to the y portion. And let's solve that. Multiply by x plus 2. So that's 2x plus 4 plus x plus 1. X equals -3. So the point should be -3, 2. And the last part, what are the x-intercepts? So recall for x-intercepts, we're going to let y equal 0. So 0 would equal x plus 1 or x plus 2. We multiply by x plus 2. That 0 times anything is 0. So we have 1, -1. And the point would be -1, 0. There's your x-intercept. And we're done.